All right, so we're on problem 22 of the final exam practice. And in this problem, we want to find the angle between this vector A, which is 3i plus 2j plus k, and the positive x-axis. So we can rewrite this A in component form. So we'll have 3, 2, 1 is our vector A. That's the components of the vector A. And to take a vector that's along the positive x-axis, we can just think of our standard basis vector I, 1, 0, 0. We know this points in the x direction. Okay, and so we know that this vector lies on the x-axis, or in other words, terminates on the x-axis. So either way, what we can do to find this angle, so essentially, the picture is going to be a little bit difficult to draw, but either way, we got 1, 2, 3 in this direction, 1, 2 in this direction, 1 in this direction. So somehow we need to draw this point here, and so this is kind of sticking out of the paper and up just slightly. But either way, this is our vector with the tail point at the origin and then head at this point 3, 2, 1. All right, so either way, this is the x-axis, right? And we know that this vector I, this is a standard basis vector that points along the x-axis. And to find the angle here, which is really, really difficult to see in my incredibly poorly drawn picture, this angle, let's call it theta, that's the angle that we want to find. And so the way that we find it is by doing the dot product of A with a vector along the x-axis, which we'll just choose to be this unit vector. So either way, we look at A dot I, and we know that this is equal to the length of A, this is by the geometric interpretation of the dot product, times the length of I, but of course it's a unit vector, so it has length 1, and then times cosine of the angle between them. So we know that theta is going to be equal to the inverse cosine of A dotted with I divided by the length of A. Okay, so in this case, A dot I is just going to be 3 times 1. All of the other components will be 0. So either way, we get 3 in the numerator. The length of A, this is the square root of 3 squared plus 2 squared plus 1 squared. All right, so the argument here is just going to be 3 over square root of 14, because we get 9 plus 4 plus 1, which gives us 14. So then taking the inverse cosine of 3 over radical 14, we get that this is approximately equal to 0.64 radians, which is approximately equal to 36.7 degrees. And so either one of these answers is fine, but just know that radians are really the only true measure of angle. All right, so on to problem number 23.